All right. To save time, we're just going to get straight to it. We're going to be doing more matrix stuff today. In just a moment, we'll look at one more 4x4 so we can call it quits on that stuff. But the DOM, hopefully you set it up something like this. B, you should have written out, minus some phantom thing that we don't know yet, equals 4A. Now, how do you think the 4 is going to affect this? Oh, yeah, affect A? Yeah. When you have a scalar times a matrix, you just multiply every single entry in that scalar. So that would be negative 12, negative 28, 8, negative 36, 20, and 0. Now, this DOM is kind of awesome because it's pretty much going to do half our lesson for us right off the bat. And then after this, everything else should go right into this. Yes? Negative here? Yes, it should. Thank you. Now, math time. 5 minus what? Excuse me, negative 5 minus what equals negative 12? Add the 5, divide by negative 1, and what is it? 7. So 7 goes here. X is a matrix, not just a number. So you're going to have to solve for every spot in this, every missing spot here. And you're going to do it the same way. Negative 1 minus what equals negative 28? Add the 1. Divide by negative 1. 27. Did anybody get those first two? This was kind of an advanced DOM, considering it had several concepts we hadn't talked about yet. So, let's see. Well, 0 minus what's going to give you 8? You can kind of figure that one out. 0 minus what's going to give you 8? Negative 8. 0 minus negative 8 gives you positive 8. 0 minus what gives you negative 36? Positive 36. 0 minus 36 equals 36. 3 minus what's going to give you 20? Negative 17. Very good. And negative 4 minus what's going to give you 0? Negative 4. Negative 4 minus what's going to give you 0? Add the 4, divide by the negative 1, and you get negative 4. And there's the DOM. And that's I guess this is my opinion. But in my opinion, that's the most complicated thing we're going to do today. So, okay, that's going to give you. Here you go. Now, before record, this is 8.3. 8.2 is kind of encompassed in 8.1. 8.2 and 8.1 are virtually the same lesson, just with more practice. So that's why. All right. Matrices. Matrices have elements to them, and this actually doesn't make any sense. And I'll tell you why in just a second. First off, elements. A32. Yes, 2 days ago when I was talking about matrices, I said, what comes first, row or columns? Row. Very good. How did I tell you how to remember that? Oh, dang it. So he was right. She remembered your XY thing, by the way, so good job. Nobody remembers the RC Cola reference? Oh, yeah. Dang it, that was a waste. All right. Oh, thanks. So I need to find it says 32nd, but the 32nd element in matrix A. So row, column, third row, second column. Are there 3 rows in my first matrix? No, so there's none for the A32. No, it doesn't exist. What about 2, 3? Second row, third column. A23, oh man, for the first matrix is negative 1, and that's all you need to put. For number 3, 3, 2, third row, second column, what's 3, 2? 1/2. What is 2, 3? Very good. Second row, third column, and A23 is negative 6. Not really. Well, maybe a little bit. Not as hard as what we've been doing. Now, the order of a matrix. Every matrix has dimensions, right? This one has 2 rows and 3 columns, so it is a 2 by 3. This one has 3 rows and 4 columns, so it is a 3 by 4. Okay? Those are the dimensions. A matrix is said to have order when it's a square. Like the one we just did. Wasn't this a 4 by 4 originally if you take out the answers? It was originally a 4 by 4. You would call this a 4th ordered matrix. If I hear 4th ordered matrix, that says, oh, it's a square, if you said order, and it's a 4 by 4. So when it says what is the order of that matrix, that must be a typo, because that is impossible if it's not a square. But the dimensions are 2 by 3, 3 by 4, neither of those have an order. Questions about any of those facts from this slide? All right. Well, I guess today write the dimensions. I assume that one of the dimensions. Today, good question. Today write the dimensions when it asks for the order. There you go. Thank you. All right. 5 and 7. Find the values for the variables that solve the matrices. For 2 matrices to be equal, just like in the DOM, okay? For 2 matrices to be equal, all the elements have to equal. So if it says these 2 matrices are equal, to solve for any missing pieces, you just set all of the corresponding pieces equal to each other. So on the first one, what does X have to equal? What does Y have to equal? Yeah, and that one was kind of simple. What about number 7? What does Y have to equal? X have to equal? 4. What does Z have to equal? We'll jump to the easy one. What does Y have to equal? Okay. There you go. Now we're going to be doing a lot more stuff with matrices, multiply, solving, adding. And sometimes we get to the test and people see this and they freak out. Like, oh, what was I supposed to do there? Just relax. Remember, if things are equal, then every piece has to equal. And that's really all you have to remember. Well, they're already equal, so there's nothing to do. Questions? All right. All right, 9 through 16, we're doing operations. These are just like the DOM. A plus B, how do you think we're going to solve that? Yeah, so what would go here? Exactly. You just add all the corresponding pieces. 4 plus 5 is 9, 1 plus 9 is 10, 3 plus 0 is 3, 2 plus 7 is 9. Now, think about this for a second. Now, this doesn't come into play on this slide, but if we have to add all the corresponding pieces, what do you think is a natural requirement to be able to add or subtract matrices? Yes, they have to be the same dimension. If they're off even slightly, if one's 4 by 7 and the other's 4 by 6, you can't do it. Because that means you're going to have some with no counterpart, so there's no way to add them. So the first thing you need to do every time you're adding matrices is write down the dimensions. If they are not the exact same, you can't do it. Now, that doesn't come into play anywhere on this page, it doesn't look like. But nonetheless, that could be a freebie on a test if you remember that. Let's see. We'll do one of each of these pieces for all the different ones. 13, we'll do A minus B. 2 minus negative 5. 7, negative 4 minus 3. Negative 7. And 1 minus negative 1. 2. Negative 4a. Let's do that for 15. What do you think we have to do for negative 4a? Exactly. And what are we going to do with b? Trick question. Nothing. Nothing. Negative 4a doesn't even mention b, so we don't mention it. Negative 4 times a, it's going to be negative 8, 40, 8, negative 56, 48, negative 48, negative 40, negative 16, 8, and negative 8. And we have scaled up that matrix, hence why those numbers being multiplied by matrices are called scalars. I think I'm going to spare you having to do 3a plus 2b. Are there any questions about how you would do 3a plus 2b? multiply 3 through by the A, 2 through by the B, and then after that, remember, word of operations, you add them together. All right then, we're just going to skip on ahead. All right, now this is exactly what we did in the DOM. And I think I had you do one of the more complex ones. This one. When you're solving these little matrix operations, you're going to do the exact same thing you did in pre-algebra. Okay? In pre-algebra, let's look at 25. In 25, well, that's not technically true. We're solving for x. Okay? 25. On all of these, we're solving for x. Now, first thing you want to do on these problems is work out everything that doesn't have to do with the x. Let's go ahead and just get these the way we need them. 4a is going to be negative 12, negative 28, 8, negative 36, 20, and 0. 3b is going to be, what is that, oh yeah, I didn't mean to square that one. I think it's one we did in the DOM. That's why I did that. All right. Well, I don't remember which one we did in the DOM. So it'd be, let's see, where was I? Negative 3, 0, 0, 9, and 12. Negative 12. Thank you. Now I'm going to go ahead and add those together. So that gives me negative 27, negative 31, 8, negative 36, 29, and negative 12. That is 4a plus 3b. And that equals negative 2x. Now, any other equation in the entire world, if I said negative 2x equals something, how would you solve for x? Divide by negative 2. And that's exactly what you're going to do. How do you think you divide an entire fraction by 2? Yeah, just put them all over 2. Well, negative 2. Negative 2. Well, you know, that's going to look ugly. I'll just rewrite it. So when we divide both sides by negative 2, you're essentially multiplying through by negative 1/2, and your finished product will be, now you can do it in fractions or decimals. I don't really care. Try not to have your matrix swaying in the wind. Positive 27 over 2 after the negatives cancel. 31 over 2. 8 over negative 2, which reduces to negative 4. Negative 36 over negative 2, which is 18. 29 over negative 2, and 6. And you've solved for x. You found 4a, you found 3b, you added them together, you divided by the negative 2, there's x. It's the exact same thing that you've been doing since pre-algebra. 2x equals 4 minus 7. The only difference is you're not just dealing with one number, you're dealing with a list of numbers. Only difference. Questions? You don't know if you have a question? Oh, no, not quite. I think we have one more slide. Multiplication. These are the most funnest. Multiplication. Now, this is, I misspoke earlier. This is the most complicated portion of the day. And people tend to get lost with this. I have to use both hands and follow along as I'm multiplying matrices. I seriously have to. Okay. First thing you need to do when you're multiplying matrices, we're going to start on 33. Write out the dimensions. A is a 3 by 2, 3 rows, 2 columns. B is a 2 by 3. When you multiply, they do not have to be the same. But, if you write them down in order, your inside numbers have to match. The columns on the first one have to match the rows on the second one. Must, period, end of discussion. If they don't, stop, you're done. There's nothing to do. The outer numbers are going to tell you the dimensions of your product. Our finished product on 33 is going to be a 3 by 3. Now, I'm going to show you how to multiply these. I'm going to tell you this. The book writes this out in much longer terms than I guess I could, but it's going to look huge if I do. Here we go. I'm going to write out a 3 by 3. I'm going to work through it rather quickly the first time, and then maybe I can slow it down second time. I need somebody to write as I do this because I seriously have to use both fingers. Well, somebody write on this. Okay. Row by column. RC column. You're going to take the first row and multiply it by the first column. That day to wear kind of a short shirt. All right. So first row, first column. 4 times 2, 8. Hold on a second. Then you go across the row and down the column. 8. What is this product? What's 8 plus negative 2? 6. I know. When you multiply matrices, row by column, you do all the elements and then add it together, and that's one entry. Let's go to the next one. Now, you stay on that row, and you go to the next column. Row, column. 12 plus a negative 4 is 8. Go to the next column. 16 plus 0 is 16. Questions so far? Awesome. Okay then. Next row. Once you're out of columns, you start over and go to the next row. 12 plus negative 1 is 11. 18 minus 2 is 16. 24 plus 0 is 24. Go to the next row. 6 minus 5 is 1. 9 minus 10 is negative 1. And 12 plus 0 is 12. And there is the product of A and B. I'm glad you don't think so. Where most people get lost is they forget to add those numbers and etc. In the book, they will show you a ginormous 3x3, and they actually write everything out. Like they'll actually write 8 minus 2 in parentheses. The only reason I don't do that is because I don't write neat enough to where to be able to discern each spot, and it looks like it's all blended together. But there is a more drawn out example in your book if you choose to use it. Okay. Let's look at 29. How many rows are in this one? How many columns? 4. This is a 1 by 4. And what is this one? 4 by 1. Can we multiply them? What's our product going to be? 1 by 1. It's just one number. So, here we go. Row, column. 1 plus 4 plus 9. Hold on. 1 plus 4 is 5, plus 9 is 14. Plus 16 is 30. Yeah, stuttering, right? I know. It's right over here. It's like the dead zone. It's 30. We just know. It's the answer 30. In a little 1 by 1 matrix. Oh, good. If they're both square, then your product will be the same dimensions as your original. I want you now to try to do 35. Try to do 35. And then we'll see if we get the same answer. At any time today, if your dimensions don't align, just write impossible, although it doesn't apply to this one. Interesting. I'm going to uncover the answer. If you're not quite done, no problem. Just finish and see if you get what I got. Anybody else get a domino? Oh, good. Good. That was weird. I didn't know it was going to happen. If, let's say as you're doing your homework, let's say you get one number, everything's the same on you and your partner, or whoever's next to you, on their matrix except for one number. Like for instance, let's say this one, you got everything the same except for that -1. Here's how you're going to know which numbers to go back and check. What's the element number for -1? 3, 2. Third row, second column. So you go third row, second column, and that's what gave us that. 9 minus 10 was -1. So that's the way you can kind of backtrack by doing multiplication.
How do you decide
Good question. So this is a 2x4, this is a 4x2, right? If the inside numbers match, you can multiply. The outside numbers are going to be your dimensions. 2x2. Every time. That's always the case. That's why this one was a 1x1 and it's just one number.
I got lost. We're going to do one by
Rows and columns. So like for this, first row, first column. So that was 2. And you kind of go across and down at the same time. 2 plus 3 is 5. Plus 5 is 10. Plus -10 is 0. Then you go to the next column. You always go columns. When you run out of columns, you go back to the beginning and go to the next row. Another common mistake is people will, after they do the first one, they'll move down and do this and then write that here. You're going to mix up the order of your matrix if you do that. You got to remember to go across all the columns, then go to the next row. Questions? The last thing of the day. Click. Oh, never mind. Apparently I was wrong. You know what? These are the exact same things we already did. We don't really even need to look at these. 4b minus 3c, we've already done that. The only difference is you have to do multiplication of 1 or 2 times first. Just remember order of operations. Multiply before you add. That's it. Down here, order of operations. What do we do first? B times C. Very good. Now, when you're multiplying matrices, order is oh so important. Please remember that. BC is completely different than CB. So just remember as you're multiplying these later, order is important. All right. There you go.